Okay, good morning, Year 11. Today we're starting our next topic and it's called the binomial expansion and Pascal's triangle. So it's using some of the information that we've learned in our combinatorics, which was our NCR, but that'll come a little bit later. We're starting off fairly simple and I think you should enjoy this topic a little bit more than our combinatorics topic. So here's the booklet. So if you haven't grabbed this booklet, it's on the desk in the classroom, so grab one of those. We're going to start with 15A, the binomial expansion and Pascal's triangle. Okay, so let's just go through some of the terminology that we need to know to start with. So a binomial is a polynomial with two terms. For example, 1 minus x or 7x to the power of 6 minus 4x cubed. Generally, we'd looked at quadratics as binomials before, but we're going to have a look at various different powers of binomials for this topic. So a binomial expansion is the expansion of a binomial raised to some power. In order to explore the expansion of these terms, we shall consider the binomial 1 plus x to start with. So we're going to start nice and simple, and this will illustrate the process, and then next lesson when I see you, we're going to apply this to a few more difficult concepts. Okay, so what we're going to have a look at today is looking at this thing called Pascal's triangle. So you need to know how to come up with Pascal's triangle yourself. So I'm just going to highlight that for us. You need to know what it is. We need to know how to form Pascal's triangle. Okay, you've seen this before. We had a little look at this on transition last year. So what we do, and there's steps over here to the left, we start with the number 1. So there's number 1 up there. And what we do with each additional row is one digit is added. And we normally add the numbers on the row above together to get the number below it. In this case, I haven't got anything to add to 1, so 1 becomes 1 over here and 1 becomes 1 again. Here, I'm going to add 1 plus 1 to get me 2. And our 1s basically end up moving as the first term and as the last term. So we're going to add 1 plus 2 to get 3, 2 plus 1 to get 3, and our 1s sit on the end. 1 plus 3 to get 4, 3 plus 3 to get 6, and so on. 3 plus 1 to get 4. And this continues infinitely. So if you want to have a go at drawing Pascal's triangle in your book and maybe going to a few more rows as some practice, that would also be great. Otherwise, what we're going to do is scroll down a little bit and have a look at how we can use Pascal's triangle. So what we're going to use this triangle for is each of the numbers in our triangle are important based on what row they sit in, and they're going to become the coefficients of our values when we do our binomial expansion. So different textbooks will look at it slightly different, but I think the best way is the way that's set up here is we're going to look at this first row being row 0. And in row 0, we only have the number 1. Row 1, example, it's got 1 and 1, etc. So if we start in with 0, that'll line up really nicely with our powers when we look at our expansion. So I mentioned up above that we'd be looking at 1 plus x. So what we're going to have a look at is finding 1 plus x to the power of 0, 1 plus x to the power of 1, and the powers are going to line up with the number for n on the left-hand side here. So in that case, our n is going to be 2. And as I said, it can go infinitely, so we're basically going to be able to find 1 plus x to the n for any n value that we want. Today, we're going to find it with the triangle. Down the track, I'm going to show you how to use the NCR to find each of the numbers within Pascal's triangle. But for today, we don't need to do that. So you may need to go back and have a look at this today to do the examples in our textbook. I don't need you to copy them down all the way to 10. Maybe just refer back, but understand how that triangle is built from the number 1. Okay, so let's have a look down here for this example. Okay, so what you will see on the left is our binomial 1 plus x, written with the powers like I have up above. And what you'll see in red over here on the right are the numbers for Pascal's triangle. And so what the red numbers are, they are the coefficients of our expansion. So when we have 1 plus x to the power of 0, we know that anything to the power of 0 is just 1. So we have 1. When we're doing 1 plus x to the 1, we're going to go, and this one's fairly simple because you know how to do the first few. You can see that 1 plus x to the 1 is just 1 plus x, but the coefficients, the 1 and the 1, come from that row in Pascal's triangle. 1 plus x to the power of 2. We look at squaring the first, squaring the last, Twice the first times the second. So we know how to expand that, but we've got 1, 2, and 1. So what we need to look at is what's happening through the progression as we move down these expansions to the 1 and the x. So because we're looking at the simplest form, we don't need to really think about this first term or the 1. But what you'll see with the x is we start with, where I've got a little arrow in here, x to the 0. So this first term is basically x to the 0, and we're building up our x's. So we've got x to the 1 and x to the 2. And that 2, or our highest power of x, matches with our 2 over here, and it will also match with the 2 on our line up here, as long as we start counting at 0. So they're all going to match up. So if let's, for example, have a look at 1 plus x to the power of 4. So power of 4 will mean that our highest power of x will be 4, and that's over here. So if we start writing it down as, and I might just write it myself down here, I'm looking at 1 plus x to the 4. I want to expand that, so I need to go to my 4th row of Pascal's triangle, and I'm going to write down 1 plus 4 plus 6 plus 4 plus 1. They're my coefficients for that expansion. And then I know I'm going to grow my x's from x to the 0, x to the 1, x to the 2, x to the 3, and x to the 4. And then if I neaten that up and get rid of the x to the 0, which is just 1, and get rid of the 1 on the power there, I've got my expansion there. So they're the rules of how we're going to expand it. Next lesson, I'm going to pop a value in that first position where the 1 is as well, and get a little bit difficult. But let's keep going, looking at this simple part to start with. So we're going to use Pascal's triangle to write out the expansion of each of these. So the first one's a fairly simple one. It's just the next row of what we've done up above. So you need to go and grab row 5 of Pascal's triangle. So if you go and grab that, what have we got? We've got 1, 5, 10, 10, 5, 1. And what you'll see is the numbers increase to a point, and then they mirror on the other side. So 1, 5, 10, 10, 5, 1. So I'm going to write those out first. 1, 5, 10, 10, 5, 1. Note I put pluses in there. There's a plus in here, so it's just a nice straightforward one. So we're looking at x to the 0, which I'm not going to write in because it's just going to be 1. I'm going to have a look at x to the 1, x squared, x cubed, x to the 4th, and x to the power of 5. Noting that that biggest 5 value there should match over here. Now let's have a look at the next one. I popped a little note at the top here to note the minus sign in here, okay, because the minus is going to do something to the pattern, and we'll have a look at what that does when we get there. Okay, so for the next one, we're going to be looking at, again, to the power of 5. So I'm going to put my same coefficients in as I did for the question up above. I'll pop the pluses in for now, but we need to note, oops, I had a 1 at the end, that we're going to have to look at minus x. So before, what I was doing was looking at x to the 0. What I'm having happen here is I'm looking at minus x to the 0, minus x to the 1, minus x squared, minus x cubed, minus x to the 4th, so on, and I'll get rid of that 1 there, minus x to the 5. And so what we need to note is that we're going to be dealing with the negative as well. So sometimes we're going to have a negative between us, our coefficients, sometimes it's going to be a positive. So obviously squaring a negative removes the negative, and so that will be the case for any positive power. If you remember back to our work in year 11 advanced, while a negative power keeps the negative. So what we're going to have there is a 1 plus, it's not going to be a plus now, is it? It's going to be a minus 5x. This negative disappears because it's being squared, so we're going to have positive 10x squared, and it's only the x that's squared. This negative still stays a minus, so it's going to be minus 10x cubed. Positive power makes the negative go away. You can check that on your calculator if you feel unsure about that. Plus 5x to the power of 4, and then we've got a negative there with an odd power, so that is going to stay a negative x to the 5. And what you'll notice is we're moving between positive and negative. So I've got positive, negative, positive, negative, positive, negative. So if we were to go back and have to go from this format here back into this format and work out what that was, I want you to note that that would happen if we have a negative sign in there. Okay, let's look at the next one. I'll change coloured pens so we can note the difference. We've got a power of 6, so let's go and grab the coefficients for a power of 6. Okay, so I've just popped those coefficients off Pascal's triangle. We've still got a 1 there, so we don't need to do anything. This 2a is taking the place of where our x was up above, so what we're going to have here is 2a to the power of 0, 2a to the 1, etc. So copy this down on your notes. It's a bit squishy there. Oops, hang on, my cube's in the wrong spot there. Just be careful there. It does get a little bit squishy here. Okay, so let's neaten that up a bit now. So again, anything with a 0 is 1, so the 1 just stays there as 1. Now we need to neaten this. So the a and the 2 have a 1, so we're going to have 12a. We've got 2 squared, which is 4, so we're going 15 times 4, so we've got 60 a squared. 2 to the power of 3 is 8, 8 times 20 is 160 a cubed. Now 2 to the power of 4, you might need to pop this in your calculator if you're not being able to do those in your head. So we've got 16, 16 times 15 is going to give us 240 a to the power of 4. We're going down in powers now, so 2 to the 5, 2 to the 5 is 32, 32 by 6 is 192, a to the 5, and lucky last, 2 to the power of 6 is going to be 64, a to the 6. Okay, so you can probably see where we're going to go for this next one, D. We've got a power of 5, so we want the 5th row. We have a negative, so we're going to have alternating negatives here with our answer, and we've got 2/3, which will act like the 2, and that's what we've got to go through. So we've basically built on all of the last few questions, and let's pop them together. So I'm going to go and grab row 5. So I've got those coefficients from row 5, and what we're going to be putting through is the whole of the minus 2/3. So I would bracket all that through and not try to do it in my head, just so that we don't have any errors. Okay, I'm not putting the 1 in there. We can pop a 2 there. Let's move that over there. Now I've got minus 2/3 to the 3rd. Move him up a little bit. Minus 2/3 to the 4th. And lucky last. Oops, and I'm forgetting my x's in there. Sorry guys. Let's pop those x's back in. See how easy it is to make a mistake. Minus 2/3 x to the 5. And now we need to neaten this up. Okay, so let's have a look. We're going to have 1 for the first part, because anything to the 0 is 1. We're going to have minus 10 on 3x. So I'm basically just expanding out the brackets. The squared is going to square the negative, so the negative is going to go away, but when we're squaring a fraction, we're squaring the top and the bottom. So I'm going to end up with 4/9, but the 4/9 is being times by the 10, so it's going to be 40 on 9. The cube's going to let the negative go through, so we're going to have, what do we got, 80 on the top and 27 on the bottom. That should have an x, and that should have an x cubed. Plus 2 to the 4 is 16. 16 times 5 is 80, so we're going to have an 80. We've got 3 to the power of 4 on the bottom line, which is 81. And we've got x to the power of 4, noting that that minus to the positive even power gives us another positive, and this minus here to the odd power is going to give us a negative. So we're going to have 2 to the power of 5, which is going to give us 32, x to the 5, and 3 to the power of 5 on the bottom is going to give us 243. That's our answer. Again, they're not that tricky. I think it's just more, there's a lot of room for error in forgetting little bits out in those ones. Now here's a hard one. I like this one because it's actually coming from our textbook, and it says an expression, we're going to look at 1 plus 2kx to the power of 6. So note there's a k in here, so you can probably see where that's going. Write down the terms for x to the power of 3 and x to the power of 4 in this expansion. Okay, so what that means is we can do what we've done up above, but we don't actually need to expand all the way up to power of 6. So it's not asking us to do that. So we can expand only part of the way, and that's going to give us a little bit of time in a question, extra time to do something else. So let's grab the coefficients for 6. Okay, I've written all those coefficients down, but we really don't need to have all of them down. So we're going to have x to the 0 and it's 2kx, so it's everything in that second part that we're going to add in here. 2kx to the 2, 2kx to the 3, so that's our third term that we're looking at, and 2kx to the 4. So I don't really want the 6 and the 1 in there in this case. There's other stuff happening. We can go dot, dot, dot. Okay, so what are the terms for x to the power of 3? So x to the power of 3 is going to have a look at this term here. So we've got 20 times 2 to the 3, k to the 3, x to the 3. So if we have a look at that, 2 to the power of 3 is 8. And we're timesing our 8 by 20, which is 160. We've got k to the 3, x to the 3. X to the power of 4 is going to have 15. And we're going to be timesing that by 2 to the 4, k to the 4, x to the 4. Oops, I just need to neaten my screen up there a little bit. Sorry, guys. Go 2 to the 4, k to the 4, x to the 4. Okay, I need my calculator for this one, I think. 2 to the power of 4 is going to give us 16. 16 times 15 is going to give us 240. So we're going to have 240, k to the 4, x to the 4. That's part A done. Part B wants us to find the coefficients of x cubed and x4. Sorry, find k if the coefficients of x to the power of 3 and x to the power of 4 are in this ratio. Okay, so I wouldn't be stressing about the find k bit. As you know, that's going to fall out. Let's look at the rest of it. Coefficients is the key word there. Okay, remembering the coefficients are the things that are in front of the x's. So if we've got the coefficients of x cubed, that's going to be 160 k to the power of 6. So we're going to say k cubed. And when we're talking about ratios, remember we can write our ratio 3:2 as 3 over 2 if we like. And I'm going to deal with it in fractions because I think that's what we're used to doing. So we've got x to the 3 is to x to the 4 is in the ratio 3:2. And if I'm going to write my coefficient of x to the power of 3, I've got 160 k to the 3. And my coefficient of x to the 4 is going to be 240 k to the power of 4. So we don't need that part in there anymore, okay? Because that's just looking at the coefficients of those. I need this part here. So we can neaten that up a heck of a lot. So let's do that now. So I've got 3 over 2. I'm going to leave it like that. Okay, the 160 over 240 breaks down to 2/3. We've got 3 k's on the top, and they're going to cancel out with 4 k's on the bottom, so we've got 1 k left on the bottom. Now we just need to cross multiply. So I'm going to cross multiply my bottom numbers, and I'm going to get 9k is equal to 4, k is equal to 4/9. Okay, so pop those in. So you can see it's, again, not tricky, but just the wording of the question, I think that's the hard one. Let's have a look at the next one. The next one is tricky. Okay, this is probably more of a harder level one. So it says expand 1 plus x squared to the power of 4. So we've got triple terms in here, but we don't know how to deal with those yet. So what the next bit does is give us a hint. And it says using Pascal's triangle by writing 1 plus x squared as 1 plus x squared. So I'm going to pop brackets around my x plus x squared over here. And then we're going to be writing x plus x squared equal to x brackets 1 plus x. So we're going to do exactly what that says. So we've got 1 plus brackets x plus x squared to the power of 4. And I'm going to replace that with an extra bracket of 1 plus x. 1 plus x. I've got lots of brackets in there to the power of 4. So if I expand this out, x plus x squared, I get this bracket here. Okay, now let's see if we can use Pascal's triangle to expand that, where this second part here is the bit that's going to go and be increased in powers. So let's write our coefficients down first. We've got 1, 4, 6, 4, 1. Note I'm spreading it out because it's going to be a long one. And now we're just going to pop in this x, 1 plus x, but note we're going to have to apply that power to the x out the front and the 1 plus x. So in this case, we're going to have x to the 0, 1 plus x to the 0. You could have probably left it in this previous format if you had liked. It would still work, but you'd have to factorize it. So the hint there they've given us is pretty handy. So we're going to go x to the 1, 1 plus x to the 1, plus x squared, 1 plus x squared. Oops, I'll put a plus in there. Then we're going to go x cubed, 1 plus x cubed plus, I don't need the 1 on the front of there, but x to the 4th, 1 plus x to the 4th. Now, you might notice something interesting there. We actually have expansions for each of these things in the brackets. So I'm going to go and expand every single thing in there using Pascal's triangle. And we're going to have to write nice and neat, and I might move up here. So our first part here, we're still going to have 1 plus. I'm going to expand this second part out to be 4x plus 4x squared. I'm going to expand within the brackets for this third part and still have the 6x squared out the front to start with. So if we square 1 plus x as we normally would, so square the first, I'm not going to use the binomial for this one, plus 2x plus 1, because we know how to do that from year 8. Was that one. So we've squared the first, squared the last, oops, twice the first times the second. We need to use binomial in this one, because it's a cubic, so 4x cubed. So we need to pop in the values for the power of 3, or row 3 in Pascal's triangle. Okay, so that'll be 1, 3, 3, 1. So we're going to pop our x's in there now. So remember, this is the one we're doing. So we're going to have x to the 0, which is 1, plus 3x to the 1, plus 3x squared, plus, I'm going to use that 1 there and write x cubed. And now we've got x to the power of 4th. Let me make this bracket a little bit bigger. We're going to pop our expansion in there, which I think from memory is 1, 4, 6, 4, 1. I need to expand that a little bit further, so you need a bit of space here. Okay, and we're going to pop in our, and there's a little mistake up here, guys, that I've made. That should be in there like that. Our x is in. So x to the 0, x to the 1, x squared, x cubed, x to the 4th. Okay, now, we're not quite there. So if you want to pause the video, you can here. We're going to expand each of these brackets out and then collect our like terms. So I'm going to do that with the video paused, and then you can see what my working is going to be. Okay, so there's my expansion, and we're going to end up with powers of 8. So now we're just going to collect like terms and neaten that up. I'll do that as well. So see if you can do that, and we'll check our answers. Okay, so there's my answer there. So what you'll note is the coefficients are increasing. So 1, 4, 10, 16, 19, and they're decreasing again. So they're mirroring each other. 16, 10, 4, 1. They're not the coefficients of one of the rows of Pascal's triangle, because that's not what we were expanding. But it's really interesting to know that they increase and decrease like that. Sorry for the long video. You're done. So you can go and have a go at the exercises now, and I popped some in the OneNote that are pre-worked for you.